A new study claims Earth's water may have arrived with the formation of the Moon. According to the giant impact theory, actually it's a hypothesis, the Earth and its Moon were created around 4.5 billion years ago when a Mars-sized planet called Theia slammed into the early proto-Earth. That collision turned the proto-Earth and Theia into a magma ocean, ejecting huge amounts of molten debris into orbit, which eventually coalesced and solidified to form the Moon. Until now, scientists had always assumed that Theia originated in the inner solar system near the Earth. That's supported by geological evidence looking at the composition of the Earth's mantle compared to that of the Moon. However, the new study, reported in the journal Nature Astronomy, claims Theia came from the outer solar system and delivered large quantities of water to the Earth. The study's authors base their claim on the assumption that the amount of water in Earth is surprising considering the planet formed in what they call the dry inner solar system. They say previous studies have shown that during the solar system's formation 4.6 billion years ago, it became structured so that the dry materials were separated from the wet materials, which are the so-called carbonaceous meteorites, which are relatively rich in water and came from the outer solar system, while the drier, non-carbonaceous meteorites came from the inner solar system. There's lots of evidence showing that carbonaceous meteorites were likely responsible for delivering water to Earth. But the authors contend it's unknown exactly when and how this carbonaceous material, and thus the water, arrived at Earth. The most popular hypothesis is a massive multi-million-year meteor storm 3.9 billion years ago known as the Late Heavy Bombardment, triggered by the planetary migrations of Jupiter and Saturn. Previous studies looking at the hydrogen to deuterium ratios in Earth's water have already shown that the carbonaceous meteorites rather than comets were the primary source. But in this new study, Dr. Gerrit Bood from the University of Munster used molybdenum isotopes to try and determine the origins of Earth's water. Bood says molybdenum isotopes allowed the authors to clearly distinguish carbonaceous and non-carbonaceous materials, and as such represents a genetic fingerprint of materials from the outer and inner solar system. The measurements showed that the molybdenum isotope composition of the Earth lies somewhere between those of carbonaceous and non-carbonaceous meteorites. And the authors suggest this demonstrates that some of Earth's molybdenum must have originated in the outer solar system. In this context, the chemical properties of molybdenum plays a key role, because as an iron-loving element, most of Earth's molybdenum is located in the core. The authors say it shows that the molybdenum, which is accessible today in Earth's mantle, must therefore have originated from the later stages of Earth's formation, while the molybdenum from the earlier phases is entirely bound up in the core. They contend the results show for the first time that carbonaceous material from the outer solar system arrived on Earth later in its formation. From this, they've concluded that most of the molybdenum in Earth's mantle was supplied by the protoplanet Theia. Its collision with the proto-Earth led to the formation of the Moon. And since a large part of the molybdenum in Earth's mantle originates from the outer solar system, this means that Theia itself also originated from the outer solar system. The authors believe the collision provided enough carbonaceous material to account for the entire amount of water on Earth. They say because liquid water is essential for life as we know it, means without the Moon there probably would be no life on Earth.